Hi, this is John Isles, and welcome to Geometer's Paradise. Today we're going to be discussing Unit 4, Lesson 1, the distance between points. We have two primary goals of this lesson. The first is that students will be able to calculate the distance between points on a number line, and the second is that students will be able to calculate the distance between points on a coordinate plane. So, let's suppose that you are going to go hiking up a mountain, and the hike is 7 miles long. So here's a mountain. Okay, and at the top of the mountain we have a sign. Whoops, out of ink. Hang on one second. This pen likes to give up on me from time to time. So we've got a sign on the top of the mountain that says something along the lines of "not the world's tallest mountain." So it's 7 miles up. And you drive your car in, and you park it at the base of the mountain. All right, and you start hiking. When you get about 3 miles up the mountain, you realize that you're hungry. Okay, so you've hiked up the mountain, you're about 3 miles up. Alright, now, how much further should you hike to get up the mountain? Sorry about that. Again, the pen is behaving badly today. So, want to figure out, all we have to do is subtract. See, anytime you want to find the distance between two objects, you subtract. So the key to the questions how far, or how long, or how much is subtraction. Now, let's suppose that instead of being on a mountain, we're on a number line. So here is a person who's green with envy, and very tall, apparently. And over here, here's a person who's very sad. They're blue. Alright, and the green person wants to walk over to the blue person. So the green person walks over to the blue person, starting at 3 and then going to 24. Well, we get negative 21. But we know that we can't move any kind of negative feet. Negative doesn't work. So we say this answer is 21, and we use the absolute value to denote that change. Because if the person over here, if the blue person walks over to the green person, we're going to go 24 minus 3, that's 21. The distance covered by the green person is the same as the distance covered by the blue person, and that's why it's always positive. Here's our official formula. You're going from A to B, and this is called distance. We find the distance by subtracting A from B, or B from A, or A from B, it doesn't matter, and taking the absolute value. The distance is always positive. Don't ever leave a negative answer for distance. Okay, so let's do a couple of examples here. Suppose I want to go from A to E. The coordinates of A are negative 2, and the coordinates of E are 7. So the distance from A to E is the absolute value of negative 2 minus 7, which is negative 9 units. It's positive 9 units. So from A to E, 9 units. We can count it out. 1, 2, 3, 4, 5, 6, 7, 8, 9. Suppose I want to go from D, which is negative 5, to A, which is negative 2. So the distance from D to A is negative 5 minus negative 2. Alright, that's negative 5 plus 2, which is the absolute value of negative 3, or 3. And again, we can check it. 1, 2, 3 units. Let's suppose that you messed this up. Let's suppose you add instead. Watch what happens. If I go 2 plus 7, I get 5. So the claim then is that from negative 2 all the way to 7, there's only 5 units. Well, that doesn't make sense. There's 5 units from 7 to positive 2. That doesn't even get you to 0. Or if I go down here, I go negative 5 plus negative 2, and your claim is 7. You're claiming there's 7 units from negative 5 to negative 2. Well, that's clearly incorrect, because 7 units will get you past 0. Okay? So if you choose to add instead of subtract, your answers don't make any sense. No sense at all. Right? So make sure that you don't answer it's okay to calculate it and get that answer. It's okay to get 7, but you need to realize you're wrong and that the error you made was that you added instead of subtracting. Okay, that's almost always what you're going to do wrong. So be aware of that and look out for it. Okay, so once upon a time there was this guy named Pythagoras. And Pythagoras was born in Greece, but he moved to Egypt, and he spent the early years of his life in Egypt. And then he moved to Babylon, and he lived for a while in Babylon before moving back to Greece, where he started sharing the things that he learned. And one of the things he learned was the Pythagorean theorem. We got a whole unit on the Pythagorean theorem in the second semester, so I'm not going to spend any more time on it, except to say that it's the square of the hypotenuse, which is the side opposite the right angle. There's a right angle here, whether you can see that or not. Shouldn't have used yellow. Is equal to the sum of the squares of the other two sides. And here we see that A is 3, I totally changed that to red. A is 3 units long and B is 4 units long. So C squared is equal to 3 squared plus 4 squared. Alright, that's 9 plus 16, which is 25 units. So C squared is 25. That means C is equal to the square root of 25, which is 5. So C is 5. Here we've got another example of the Pythagorean theorem. And when there's no right triangle drawn, you have to draw one yourself. So you draw a horizontal component from A under C, and then a vertical component from C down to A. So this forms a right angle. I call this the X component and the Y component. And the length of the X component here is 12 units. And the length of the Y component is 8. So the distance squared is equal to 12 squared plus 8 squared. That's 144 plus 64, which is 208. And the square root of 208 is like 14 and some change. Here, hang on, I got a calculator. Alright. Dead air. Let's see. Oh, this calculator doesn't do square roots. Ah. Right, there it is. Square root 208. Boom. 14.42. Okay, so there you go. 3 decimal places is better than 2, but if you put 2 down there, that'll be alright for the regular group. Honors group, 3 decimal places. Okay, oh no, we can't count. Well, that doesn't change anything. Alright, we're still going to do a horizontal component and the vertical component, but this time, instead of counting, we're going to have to subtract. So X is equal to 37 minus 61. That is not a 6. 37 minus 61. And 37 minus 61 is negative 24. Okay, we'll just take that as 24. Y, though, is negative 26 minus 19. Well, minus a negative 19. So that's negative 7. The distance formula then is 24 squared plus 7 squared. That's 24 squared, 576. Sorry, I just did this with my other class, but totally slipped my mind. And we add these up. We've got, oh boy. Hang on. 625. There it is. Whew, that was crazy. D then is equal to the square root of 625, which is 25. Okay, so the square root of 625 is 25. That was not my finest moment, was it? Alright, a couple easier ones. Let's compute the distance from E to F. Alright, so here we go. We got to get some ordered pairs down. So E is negative 2, 4, and F is 6, 7. Our X component then is negative 2 minus 6, which is negative 8. Oh boy. And our y component is 4 minus 7, which is negative 3. D squared then is equal to 8 squared plus 3 squared. That's 64 plus 9, which is 73 units. D then is equal to the square root of 73, and that, let's see here, square root of 73, 8.544. Okay, let's do another one. A has the coordinates negative 8, 6, and B has the coordinates negative 4, 3. So the x component is negative 8 minus a negative 4. That's a plus 4, so negative 8 plus 4 is negative 4. And y is 6 minus 3, which is 3. D squared then is 4 squared plus 3 squared, which is 16 plus 9, or 25. D is equal to the square root of 25, which is 5. One more, maybe two more. Okay, in fact, I'm going to do these in parallel. Let's get ordered pair for G. G is negative 6, 2. And for H, which is negative 6, negative 5. If you're struggling with this, one of the things you can do to help keep things straight is to write them over each other like this. And then you can just think that you need to subtract the x's and subtract the y's. So x would be negative 6 minus negative 6, which is 0. Y would be 2 minus a negative 5, which is 7. Now, I know some of you guys are already thinking about the answer. That's okay. That's good. I'm going to work this through, though. 0 plus 49 is 49. So D is equal to the square root of 49, which is 7. Okay, now, I'm going to ignore that answer for just a second, and let's go and do C and D here real quick. C has the ordered pair negative 2, 2. D has the ordered pair 3, 2. So our x component is negative 2 minus 3, which is negative 5, positive 5. Y is equal to 2 minus 2, which is 0. So now D squared is equal to negative 5 squared plus 0 squared. That's 25 plus 0. So D is equal to the square root of 25, which is 5. What we want to notice here is that our answers have already been computed. Whenever you have a 0 component, the solution will be the other component. So you don't have to do the Pythagorean theorem at all. Whenever you have a 0 component, the answer is simply the other component. So the distance is 7. Here the distance is 5. Make sure that you don't say the distance is negative 5, though. That's bad. All right? So your homework assignment will be to do many more of these. Plus, we've got a little bit of information about the Cartesian coordinate plane and the Pythagorean theorem for you guys to check out on your homework document. All right, good luck, and I will see you in class tomorrow.